Okay, so this is going over number 3 from homework 11.2, and this is a hard question for sure. So especially because they give us just generic radius r, and then say each one of these is another r, right? So what I always recommend doing actually is you can just pick a number for r, like 1 or 2 or 3 or something, and then it'll work out the same no matter what number you pick for r. That being said, I thought I would make this video and just go over if we just treated it as r. So basically our first circle would be radius of r. This one would be 2r because we'd have an r and then another r. And then we just keep going out, one more r each time. So this one would have a radius of 3r. This one would have radius of 4r, r plus r plus r plus r plus r. Okay, so then the area, remember, for a circle is pi radius squared. So here it's just pi radius squared because radius is just r. But this one gets a little weird. It's going to be pi times the radius, which is 2r this time squared. So that comes out to be 4 pi and then radius squared, right? Because this square applies to both the 2 and the r. So similarly here, this one's going to be pi times the radius, which is 3 times r squared. So that'll be 3 squared 9 pi radius squared. All right. And then the last one would be pi times 4r squared. So 4 squared is 16. So you have 16 pi radius squared for the area. Okay, and so then the probability we land on the bullseye. So the bullseye is just this one in here, which is the first one. So we divide that area, which is pi radius squared. That's the first area here, by the entire thing, which is that 16 pi r squared. Okay, and what you'll find is that the pi and the r squareds cancel. So you just have like 1 over 16. And that's your chance that you'll hit the bullseye if it's randomly landing inside of there. Okay, and that would have been the same no matter what you picked for r, right? Because the r essentially cancel out, they don't factor into this percentage. Okay, so for the green region gets tricky because we have to add this plus this. And so that first circle is actually a donut. So if it was all filled in, it would be 4 pi r squared, but then we have to take out this middle yellow part. So we're going to subtract these two areas. So that's 4 pi r squared minus 1 pi r squared. So you get 3 pi r squared. So that inner ring there is 3 pi r squared. All right, the bigger ring, again, I'm going to subtract. So I'm going to take this whole big circle here and subtract out the one circle inside of that. So it's basically this green one minus, so I'm subtracting these two essentially. So that's 16 pi r squared minus 9 pi r squared, and that's going to give you 7 pi r squared. Okay, so the green part total is these two added together. So that was the outer ring, and that was the inner ring. This is the outer ring, so we add those together. So the green part is 10 pi r squared, and you're going to divide that by the whole thing again, which is 16 pi r squared. That's the whole thing. And again, what happens is the radiuses cancel out, the pi's cancel out, so you end up with 10/16, which simplifies to 5/8. So the chances you randomly hit one of the green parts is 5 out of 8. All right, so that's pretty tricky. But again, if you wanted to make R 1 or 2, that'd probably make it a little bit easier problem. All right, thanks for watching.